Now that we've been working with triangles a little bit, finding areas and doing some right triangle trigonometry stuff, we start kind of looking at what we can do with non-right triangles. So the first thing that we're going to look at here today is what's called the cosine rule, or sometimes called the law of cosines. We really want to use this in the case where we have a non-right triangle and we want to solve for some of the sides or angles. As you see down at the bottom here, the law of cosines can really be written in any one of three ways. In your information booklet, you're going to have one of those ways listed there. But if we take a look at in the first part, right here, a squared equals b squared plus c squared. Now that part of the law of cosines kind of looks like a Pythagorean theorem. Really what the law of cosines is the Pythagorean theorem with an extra accommodation for not having a right angle. And this is that extra accommodation. Okay? So a squared equals b squared plus c squared minus 2bc times the cosine of alpha. Now notice that alpha is the angle that's across from side A. Beta is the angle that's across from side B. And gamma is the angle that's across from side C. Okay? So with that being the case, we can notice some patterns here. Notice that if a squared is on a side by itself, the angle associated with that, the angle across from that, is the angle that we're trying to identify. So here we have a squared and alpha. In this one we have b squared and we have beta. In this one we have c squared and we have gamma. Those are related. They're the sides and angles that are across from each other. The other thing to notice here is that the other two sides, when we have a squared on the one side, b squared and c squared are the other parts of that Pythagorean theorem. And then we also have b and c here. So we have a and c, and then ac. We have a and b, and then ab. So there are definitely some patterns here to recognize and to utilize as we work with the law of cosines. Now, one of the things that we're going to be working on with that is identifying side lengths and angle measures based on some given information. So let's take a look at an example here. We have a non-right triangle. We're given that side A is 13, side C is 6, and angle beta is 20 degrees. Now, if I wanted to set that up to solve the triangle, let's solve for side B first. So we could say then that b squared, side B, equals a squared plus c squared. That's the Pythagorean theorem part of this, minus 2ac times the cosine of beta. Again, if we have b squared here, this is going to be the angle that's across from that. So plugging in what we know, we find that b squared equals 13 squared plus 6 squared minus 2 times 13 times 6 times the cosine of 20 degrees. When we use our calculator then to evaluate, now all of this stuff here ends up being evaluated. We have to follow the order of operations. So first we have to square the 13 and the 6. Then we have to multiply this stuff together. And then we can finally add the three things, add and subtract what we have from there. So don't forget the order of operations as we evaluate here. That's going to be important, especially later on when we look at another example. When we do that in this problem, 13 squared plus 6 squared minus 2 times 13 times 6 times the cosine of 20 gives us approximately 58.41 if we round that. And then when we take the square root of b is 7.64. So we know what side B is. If I'm solving the triangle, I still need to know two of the angles. So let's see if we can find angle alpha. Now, if I want to find angle alpha, then I'm going to need angle alpha in my formula for the law of cosines, or the cosine rule. So in order to get alpha in the formula, I would need to do a squared equals b squared plus c squared minus 2bc times the cosine of alpha. Now, again, plugging in what we know. A is 13. B we just found was 7.64. C is 6. And we can plug those in again for B and C here. And we're solving for the angle alpha. Now, going through and evaluating here, we end up with 169 equals 94.3696 plus 30, I'm sorry, I just skipped ahead a little bit here. When we evaluate this part together, we end up with 94.3696 minus 91.68 times the cosine of alpha. Now, the thing that a lot of students will do with this is mistakenly try to subtract these two things. We can't do that because the cosine of alpha really right now is a variable. So I can't subtract the 94.3696 and the 91.68 before I multiply the 98 or 91.68 times the cosine of alpha. Just like if we had 2 minus 3x, I know that I have to do 3 times x before I can do 2 minus 3. We wouldn't subtract the 2 and 3 there, so let's make sure we don't subtract those numbers in this one either, okay? We still want to solve for alpha. So the first thing I would need to do is subtract the 94.3696. We would end up then with another value coming up here. I didn't write that one down, so I'm going to also divide by negative 91.68. So we're subtracting 94.3696 and then dividing by negative 91.68. We end up with the cosine of alpha equals negative 0.814. Okay? And again, you can go through the algebra there and solve for the cosine of alpha to show that that's the case. Now, to find alpha, then I have to do the inverse cosine of negative 0.814, because again, if the cosine of alpha is this answer, then the inverse cosine of negative 0.814 would give us that angle alpha. And if your calculator is in degree mode, the inverse cosine of negative 0.814 gives us 144.5 degrees. Okay? So moving back up to our diagram here, this is 144.5 degrees, and side B was 7.64. Now, the last thing that we need to do to solve that triangle then is we need to find gamma. Now, in this case, remember that alpha plus beta plus gamma has to equal 180 degrees. If I know 2 of those angles, I could find the third one. In this case, gamma is going to be 180 minus 20 minus 144.5. And when we subtract those, we get gamma is 15.5 degrees. Okay? So this is 15.5 degrees. So now we've solved the triangle, and we know all the side lengths and all the angle measures. And again, we can only do that by using the law of cosines, because SOHCAHTOA won't work. We don't have a right angle, so those ratios don't hold up in a non-right triangle. You can't use the Pythagorean theorem because, again, that only works with a right triangle. So, we're kind of down to having to solve this by using the law of cosines, or the cosine rule. Let's look at another example. So if we want to find an angle, maybe instead of a side length, which we did in the previous example, we can actually solve this law of cosines for that cosine piece. Okay? And again, this is going to be in your information packet. I believe the form that is in your booklet for each of these, I'm pretty sure, is this one for the law of cosines, the initial one we looked at. And with the other form, I believe this is the one that's listed. Now, keep in mind that those patterns, there's 3 ways that we list it, but those patterns remain the same, so we can kind of generate the other forms of that if we want to find angle A or angle B. but that one will be given to you in your information booklet. It's not something you necessarily need to memorize, more so than just kind of looking at the pattern if you need something else. Now, if I want to then find an angle instead of side length, let's take a look at an example here. We could find the measure of angle BCA given some information here. Now, any of these triangle problems, my first thought is I want to draw a diagram. So let's draw a triangle. It doesn't matter what it looks like. We'll label it ABC. And the information here, the problem tells us that side AB, that would be this side right here. Side AB is 7 centimeters. Side BC right here is 5 centimeters. And side CA, that's this side here, is 8 centimeters. So if I know the three sides, we want to find the measure of angle BCA, that would be this angle. We can also name that angle C. Okay? So in this one, we could say the cosine of angle C equals side A. Now side A, if this is angle A, then this would be side A. So 5 squared plus side B. If this is side angle B, then this is side B. So 5 squared plus 8 squared minus, if this is side C, then, or angle C, then this is side C. So minus 7 squared over 2 times 5 times 8. Now when we calculate that, we get the cosine of angle C equals 0.5. You can verify that with your calculator if you'd like. But 5 squared plus 8 squared minus 7 squared over 2 times 5 times 8 gives us 0.5. So angle C then would be the inverse cosine of 0.5. And in degree mode, that would give us 60 degrees for that angle C. So again, in some cases, it might make it easier if we're trying to find an angle to use this version of the law of sines or law of cosines, law of cosines in this case, or sometimes called cosine rule. It might be more convenient to use that case because we already have that part with the angle that's solved for. Can maybe reduce some of the potential for mistakes. Now, looking at some further problems here, an application problem. If we have 2 ships that are leaving a port, one traveling 22 kilometers per hour, the other traveling 31 kilometers per hour, and their courses diverge by 38 degrees. Really, here's what this means. We have this port right here, and the 2 ships are leaving the port at the same time. One is going 22 kilometers per hour, the other is going 31 kilometers per hour. And if we want to know how far apart they are after 3 hours, we really want to find that distance. And they also tell us this is 38 degrees. Okay? Now, after 3 hours, this first ship, the one that's traveling 22 kilometers per hour, has traveled 66 kilometers. 22 kilometers per hour for 3 hours, that would be 66 kilometers. The other ship, traveling at 31 kilometers per hour, after 3 hours has traveled 93 kilometers. So we know 2 of the sides and an included angle in this case, so we could use the law of cosines to figure that out, to figure out the third side, the length of that third side. In this case, we're trying to find side P. We'll call this side P. So in this case, we could say P squared equals the 2 sides, so 66 squared plus 93 squared minus 2 times 66 times 93 times the cosine of angle P, which was 38 degrees. Now, evaluating in the calculator, if I am careful, follow the order of operations, and evaluate that, P squared would equal 3,331.4, which means then that P, that side, the distance between the 2 ships, would be 57.7 kilometers. So So after 3 hours, those two ships would be 57.7 kilometers apart, and we have what we were looking for. Okay. Now, notice that in the problems that we've done so far, we've been given some certain information. We've either had two sides and an included angle, or we've had three sides. Those are our two conditions in which we can use the law of cosines. If we have other conditions, we don't really have the information necessary to be able to use that cosine rule. So we're really looking for a side angle side condition or a side 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 condition in our triangle to be able to use the cosine rule, or what we call the law of cosines. Let's look at another example. So we want to find the length of side AC corrected 2 decimal places if side AB is 12 centimeters, angle B is 58 degrees, and angle C is 39 degrees. Let's start with the diagram. So I want you to pause the video, draw a diagram, label it, and see if you can set up the law of cosines for this problem. Now, the diagram that we should end up with, I'm just going to draw a triangle. It doesn't matter what it looks like. We're going to label it A, B, and C. We don't have to necessarily draw it to scale. We know that AC is what we're trying to find. So I'm going to call that side B because it's across from angle B. Side AB is 12 centimeters, angle B is 58 degrees, and angle C is 39 degrees. So notice now we have an angle side condition. We have two angles and a non-included side. Okay? Angle side condition. Now, an angle side angle condition would be if I knew that this was 12. That would be angle side angle. In this case, that's not the one that we have. So I know that naming these conditions sometimes can be troublesome, but if we kind of follow with how we can name these, then it might be a little bit easier to distinguish what we're trying to do. So if I try to set up a law of cosines here, there's a variety of different things we could do. We could say that b squared equals a squared plus c squared minus 2ac times the cosine of angle b. But when I plug the stuff in and try to solve for b, we don't know what side A is. We know side C is 12 though. And I don't know, I do know it's angle B. The problem though is at this point we have two variables in our equation. I can't solve one equation with two variables. No matter which form of the law of cosines or the law of the cosine rule that we use, we're always going to end up with two variables. So in this case, this angle side condition, we can't use that law of cosine, but we can still solve the triangle. What we want to use is something called the law of sines, or the sine rule. So in the sine rule, we really can set up a proportion comparing the sine of any two angles in the triangle over the corresponding side. So for instance, if I knew angle A and angle B and side B, I could find side A. Because sine of angle A over side A equals sine of angle B over side B. Or if I knew B and C and side B, I could find side C, because sine of B over B equals the sine of C over C. So we can set up a proportion. We only need two of those three parts, and three of the four unknowns to be able to solve that. So let's look at applying that. This would be something good to have in your notes, the sine rule, as well as the cosine rule. So if you didn't write that cosine rule down, I'd probably go back and get that later. But looking at that same problem, we have the same diagram we were working with before, but now instead of trying the law of cosines, let's see if we can use the law of sines to solve this. So in this one, we can say the sine of 39 degrees over 12. It's the sine of angle C over side C, with angles and sides are across from each other, 39 over 12, equals the sine of 58 over side B. So notice with that proportion now, we can solve for B. if I'm going to solve that one for b, we could start by cross multiplying. So in this one, b times the sine of 39 equals 12 times the sine of 58 degrees. And solving for b, we get b equals 12 sine 58 over the sine of 39 degrees. Evaluating that in the calculators in degree mode, we end up with 16.2 centimeters for b. And if we needed to solve anything further, we could continue then to solve maybe for angle A or for side A. But in this case, all we were asked for is side B, so we could stop right there. So we can apply this proportion. We can solve for something else in that triangle by setting up a proportion where the angles and sides are across from each other. Okay? Let's look at a couple others. Now, there are some cases here where we run into some troubles because there are actually two possible angles at times. So looking at this next one here, triangle ABC, again, just setting up a random triangle. I like to just label that just so I can see a picture of what we know. AC is 7, AB is 11, and angle B is 25 degrees. Now, using the law of sines, or the sine rule, to solve this, we could say that the sine of 25 over 7, this angle over this side, equals the sine of C over 11. So pause the video, solve that for angle C, and see if you can figure out what that might be. When we solve this one, we end up with 7 times the sine of C equals 11 times the sine of 25 when we cross multiply. So the sine of C then would be 11 times the sine of 25 degrees all over 7. And we get 0.664 as a result. Now, taking the inverse sine of 0.664 then, we get C equals 41.6 degrees. So that's one possible answer. Here's the thing about this triangle though. If we look back at our unit circle, if 41.6 degrees, we'll just mark that right there, is one possible answer for the sine. There's another possible answer over here. That would be 180 minus 41.6. Now if we take 180 minus 48.6, we get 138.4 degrees. Now, checking those possibilities. If one triangle had a 25 degree angle, a 41.6 degree angle, the third angle would be 180 minus 25 minus 41.6, and we could figure out what that third angle would be. The other possibility is that it could be 25 degrees, 138.4 degrees, and a different third angle. So we actually have two possible triangles here. We're going to talk a little bit more about that case in class on Monday. But what we're going to be seeing is that there really are two possibilities for the triangle, and we have to solve for both possibilities. Okay? Now, this last example, we look at another triangle again, triangle KLM. In triangle KLM, it says that angle LKM, that's this angle right here, measures 56 degrees. Side LM is 16.8, and side KM is 13.5. So when we set up our law of sines, or the sine rule to solve this one, we get the sine of 56 over 16.8 equals the sine of L over 13.5. Solving for the sine of L, I'm going to skip a couple steps here and go right to what we get. It'd be 13.5 times the sine of 56 degrees all over 16.8. And calculating that and solving for L. L ends up being 41.8 degrees. Now, the other possibility, again, looking at our unit circle, if the sine of 41.8 is this answer, which I believe if we calculate that is 0.666, then 41.8 is there. The other possibility is over in that second quadrant, and it would be 138.2 degrees. Okay? So we really have two possibilities for an angle L that would satisfy the equation that we started with. Now, here's where this one becomes a problem. 56 plus 41.8 plus some other angle could give us 180. The problem with the 138.2 degrees is that 56 plus 138.2 is already greater than 180 degrees. 56 plus 132 actually is 194.2 degrees. So if two angles already add up to more than 180 degrees, that angle is not a possibility. Okay? It doesn't give us a possible second triangle. So in this one, we only have one triangle. Now, kind of a weird case here, a weird type of condition that we run into. And if you look at what we have here, in this case, we have two sides and a non-included angle. Here too, two sides and a non-included angle. So when we look at that side-side angle condition, it's one of those that that tends to become a problem because we get two possibilities, or we potentially could have two possibilities for the triangle. It's one that we need to watch out for. When we get a side-side angle condition, we have to be careful to check for a second possible triangle for our problem. And again, we're going to talk more about that side-side angle condition in class on Monday. So be ready for that. We'll kind of talk a little bit more about what that is. Now, just as kind of a summary here of triangles. If we're given a problem involving a triangle, we need to decide how to solve that problem. My suggestion would be to start with the easiest thing first. That would be what we know the most, or what we know the best probably, which is SOHCAHTOA and pythagorean theorem. We can use that when our triangle that's given is a right triangle. We can't use it for a non-right triangle. We can only use that if we have a right triangle that's given. If the triangle is not a right triangle, then we need to use either the sine rule or the cosine rule. So we could use the cosine rule if we know three sides of the triangle, or if we know two sides and an included angle. So really the side and the side angle side condition would be the two cases where we want to be using the cosine rule. If we don't have a right triangle, if we don't have a side condition, and if we don't have a side angle side condition, then we can use a law of sines, which would require that we have one side and two angles. So that would be the angle side or the angle side angle condition. Or if we had two sides and a non-included angle, then we might end up using the sine rule there. But be careful again of that side angle condition, because in that case, we could end up with the two triangles. Again, we're going to talk a little bit more about this ambiguous case on Monday. So that's all for the non-right triangle stuff. Using the sine rule and the cosine rule. Be ready to work on some of those things on Monday. We'll take some questions from the video and work from there.